again, I spent that whole of last lesson introducing this idea of a radian. I really try and emphasize this idea of understanding. Mitch, can you tell me, in your simplest words, what really is a radian?
It's a degree of measurement around the circle.
Yeah, it is a degree of. Oh, is it a degree of measurement?
You measure things.
Is it
with
really?
its distance
What
around
are we?
a
What are we
certain
measuring though?
You're using it a distance to
Circumference,
measure an angle.
To angle distance.
Okay, we've got some ideas coming. Let me just come back to what I introduced in the first instance. Right? Jesse, for this one, C over D, right? For any circle, what is that equal to?
I was thinking that's the alpha times beta
Pi.
formula, but pi.
Right, it is, right? Why is that? It's basically saying how many times does your diameter fit inside your circumference, and it's exactly, every time it's exactly pi. Now, then I introduced a new way of looking at what if we halve this? What if I looked at the radius? So we've got both radii here, and instead of looking at, you know, the whole circumference, what if I just looked at some length? Let's call it L.
That's called a
Let's
radian.
call that the arc length. Okay.
Wrong then.
Okay. When I look at this idea of radians, right, I'm saying how many times does the distance of the radius fit inside that? How many times does the radius fit inside that? How can I rewrite that? How can I rewrite that in this methodology here? So
In terms of pi.
yeah, in terms of R and L, right? Because here, right, I'm saying how many times does the diameter fit inside the circumference? The question I'm asking is how many times does the radius fit inside
The arc.
the arc length? Yeah. Well, how can I write that as a fraction instead? So like similar to what I said.
Would it be
Well, which one's over which one?
L over R?
It's L over R because it's saying how many times does R fit inside the arc length, right? So that divided by that, what would that be equal to?
No, it wouldn't.
Damn it.
D.
2
C.
It would depend, wouldn't it?
That's
Pi-
actually
pi and
that's
2.
no, it's not. Oh,
Pi
no,
and 2.
no, because that was when I was looking at half of a diameter, right? I was like, I'm saying for any arc length now, right? For any arc length. It depends on what?
The angle.
Yeah, that's theta. Our definition of a radian is, it's saying, right, how many times does a radius fit inside
Looks like an Easter egg.
how long my arc length is? That's why we're looking at distance. Why this is powerful, right? Before, when I wrote down theta, it would just have some arbitrary number and degrees. It didn't really mean anything. It was just something that we came up with. But now theta actually has a definite definition when we use radians, right? We're not using degrees anymore in radians. Why this is good is because it allows me to use this formula and instead find other things. And this is our first part of the circle we're looking at. We're looking at the arc length.
Arc length, man.
Write that down for me.
Interesting. I love arc length.
If I was to have the other information here, right? If I had the radius and I had theta in terms of in radians, I could just rearrange that equation, couldn't I, to find the arc length? What would I need to do to get L as a subject here? Yeah, you just multiply both sides by r. You get r times theta.
Genius.
Yeah. And that's the first formula that we're going to look at, the formula for an arc length.